Yubu, good to see you as well. Thanks for joining again.
So we are live and recording is on, and now I'm going to start the webinar. Then floor is yours. All the best to all of you.
All right, thank you everyone for joining. Dwaipan, do you want to start the presentation?
I thought you'll just say some words so that we can start off.
All right, good evening, good afternoon, good morning, good night to people from all around the world. Thank you so much for joining. I'm Alex Hoogeveen-Rutter of the International Solar Alliance, and we're delighted to have you here today. I think going forward, this is going to be an increasingly important topic. Sustainability standards for solar manufacturing. As we all know, solar needs to grow 5 to 10 times in terms of the manufacturing capacity in the next 10 years. And there's a huge opportunity for new manufacturers all across the world to compete. And we want to make sure that there's a level playing field and that everyone has an opportunity to raise their game and create solar manufacturing in the most sustainable way possible. And that's why we're delighted to have the Global Electronics Council, as well as the Ultra Low Carbon Solar Alliance, introduce this topic and hopefully support manufacturers and developers around the world in ensuring that their solar module production and capacity is more sustainable. So that's all I have. I really want to. So with that, I'm going to hand you off to Michael Parr from the Ultra Low Carbon Solar Alliance. To introduce the standard in particular, as well as the overall sustainability picture when it comes to solar module manufacturing. Thanks, everyone. Off to you, Michael.
Thanks very much, Alex. So what we're going to show you all today is a broad overview of the EPEAT Type 1 Eco Label for photovoltaic modules and inverters, give you a little background around why the Eco Label is developed and some of its key attributes, and then do a bit of a deep dive into the carbon footprint criteria, which were most recently added. You will find this to be a relatively detailed presentation because this is quite a detailed standard, but we really look forward to some Q&A at the end, and some open discussion around the role that an eco label like this can play for the industry. So, do I put on the next slide? So a little context on why an eco label and why attention to carbon footprint in PV manufacturing. This is from data from the IEA special report on the PV supply chain, which many of you will be familiar with. And not surprisingly, as the PV supply chain has gotten highly concentrated in East Asia, which has a relatively high carbon intensity power grid because of the still wide-scale use of coal, particularly in the manufacture of the most energy intensive components of PV, like polysilicon, that the Chinese supply chain has a much higher level of carbon intensity per finished product than lower carbon economies such as US and EU. Next slide. What this means is if the growth in solar manufacturing over the next 20 years occurs as it has over the last 20 years, predominantly in China, the growth in carbon emissions associated with that manufacturing would also rise substantially. The light blue bar is the trajectory for solar emissions from PV manufacturing, if that all remains concentrated in China. The dark blue bar, for comparison, are emissions from the global aluminum industry, one of the more highly emissive heavy industries globally. And you can see that if we don't change the trajectory here, PV manufacturing carbon emissions will rise to the point that they exceed those from aluminum. And so we have the opportunity to change this and avoid significant amounts of carbon emissions in the coming years. An estimate on the order of 30 gigatons by 2040 from NREL, and an estimate of 15 to 20 gigatons by 2030 from the Clean Energy Buyers Institute. Next slide. So there's a lot of academic work that underpins this. I've just highlighted a few of the studies that really dig into these differences in carbon intensity in PV manufacturing, if you want to look into the background. In response to this, a number of governments have implemented policies related to PV sustainability that have already begun to affect the market. Many of you will be familiar that France has now had for a little over a decade a carbon footprint standard in its public tenders for PV projects. And that system has detailed criteria to calculate life cycle carbon footprint, and modules with lower embodied carbon get both higher scores in considering their bids, and they also get a higher price in the purchase price. In 2020, South Korea implemented a very similar program to France. And just last year, the US government adopted the EPEAT eco label as the purchasing guidance for solar for the US federal government. We've also seen some other sustainability related policy changes. You will be familiar with the US Uyghur Forced Labor Prevention Act, which prohibits the import into the United States of solar products that were made with forced labor. And a number of countries are also looking, and EU has already begun to pilot implement the so-called carbon border adjustment tax, which basically puts a carbon price on an import based upon the carbon footprint of that product. The US Congress has looked at this, and there are several bills that have been introduced to do it in the US as well. And so we can see that there's a broad trend globally towards pushing for lower carbon, more sustainably manufactured solar. Next slide. We've also seen private sector moving in this direction. Lightsource BP, which is a very large solar developer, has been specifying and buying large volumes of EPEAT registered modules in the US because of their desire to reduce their scope 3 emissions in their supply chain. And the Clean Energy Buyers Institute, which is an NGO that gathers together large developer corporate and utility PV buyers has also embraced low carbon solar using the EPEAT Eco label and are building preferences for EPEAT registered modules into their generic buying guidance that they provide to their members. So with that background, let me pass this on to Debbie Graham-Clifford from the Global Electronics Council to start to walk through what is behind and what is in the sustainability criteria for the EPEAT Eco label for solar.
Thank you, Michael.
Debbie, before Doipan here, just before you start, I'll just, for the benefit of the audience, I'll just introduce Mr. Michael for everybody will understand where he's coming from. So Mr. Michael Parr is the Executive Director of the Ultra Low Carbon Solar Alliance, which is a coalition of solar manufacturing companies which uses the market forces to decarbonize the solar supply chain, basically trying to make clean energy more cleaner. He has around 40 years of experience in manufacturing, energy, sustainability, and carbon mitigation. And I gave his introduction later because for the audience to understand, he's a subject matter expert on the session we are having right now. And just to add to that, I welcome Ms. Debbie. She, as the Director of Global Development, Debbie, she drives and measures the purchaser demand and manufacturer supply of the sustainable IT products and services, including the standard, the EPEAT standard for solar product category. Her outreach focuses on the GEC's initiative to advance decarbonization of solar panel productions. And so please, Debbie, you take forward from this. Thank you so much.
Thank you, Doipan, and thank you, Michael. As Doipan just indicated, I'm Debbie Graham-Clifford from the Global Electronics Council, and I'll cover, as Michael noted, some of the attributes of the EPEAT Eco label. And as you're looking here at the attributes of the EPEAT Eco label, which, as I mentioned, owned and managed by the nonprofit, the Global Electronics Council, I will begin by saying that EPEAT, or the full name, the Electronic Product Environmental Assessment Tool, which is, a very large mouthful to say, is a Type 1 eco label, covering electronics and technology services. So for anyone that may not be familiar with that term, eco label, here is the actual definition as per the Global Eco Labeling Network, known as GEN. Eco-labeling is a voluntary method of environmental performance certification and labeling that is practiced all over the world. And an eco-label identifies those products or services that are proven to be environmentally preferable within a specific product category. And contrary to regulations, which can, in some cases, disincentivize certain behaviors, eco-labels provide manufacturers with an opportunity to innovate and competitively differentiate their products on sustainability factors. And among the hundreds of environmental labels in the marketplace today, Type 1 eco labels are recognized by the United Nations Environment Program as the most reliable. And next slide, please, Doipan. So GEC is committed to developing life cycle-based criteria through a balanced voluntary consensus using an innovative process actually developed by GEC called the Dynamic Criteria Development Process, which you'll see outlined here on the slide. And the process actually contains the 5 elements of a voluntary consensus process, which are openness, balance, due process, appeals process, as well as consensus. And this, of course, aligns with the ISO 14024 standard for Type 1 eco labels. And just as a guide in terms of what you're seeing here on the slide at the moment. So this is the process that we followed to actually create the criteria for the EPEAT photovoltaic module and inverters, or EPEAT for solar category. And the same process that we follow anytime we look at introducing a new product category. So beginning with a state of sustainability research that you see as the first step here on the left. And there are several stops along the way during this process before we end at final consensus and actual publication and adoption of a new set of EPEAT criteria where we do invite public consultation. So again, a completely transparent process from beginning to end up until the time that we actually end with, a set of criteria for a specific product category, and in this case, of course, solar. And next slide, please, Joy Payan. So turning to the actual NSF 457 standard for photovoltaic modules and inverters, this is one instance where I'll actually read from the slides, which I don't normally do, but I think this information is very important. So I will touch on these points briefly, and of course, if there are questions related to this, we can cover those at the end. So the actual purpose of the standard as it's written for photovoltaic PV modules and inverters is to establish product sustainability performance criteria and corporate performance metrics that exemplify sustainability leadership in the market. The standard does provide a framework and a standardized set of performance objectives for manufacturers and their supply chain in the design and manufacture of PV modules and inverters. For purchasers, the standard provides a consensus-based definition of key sustainability attributes and performance metrics, alleviating those purchasers from the arduous and sometimes complex task of defining sustainability performance for PV modules and inverters. And this point is very important. The standard itself was developed based on the principle that only sustainability leadership products, so those in typically the top third of the marketplace, are actually expected to qualify to the standard at the bronze level at the time of the publication of this standard. And only a few products are expected to be able to meet the highest performance level, which is gold. And EPEAT is unique in the sense that it is a tiered eco-label. So as I just mentioned, the first tier is bronze. That would encompass where the manufacturer has the ability to meet optional criteria and receive additional points so that they of course can reach those higher tiers for their products. So the standard is continually maintained and periodically reviewed to ensure that the definition of sustainability leadership, as it's reflected in the performance criteria, progress with the evolution of technology and services and sustainability and environmental improvements in the product sector itself. And next slide, please, Joy Payan. So as you'll see here, EPEAT criteria are grouped into priority sustainability impact areas, which are climate change mitigation, so reducing greenhouse gas emissions within the manufacturing supply chain and a product's use. The sustainable use of resources, or otherwise known as circularity, I think is the term that most people know this by. This covers how products are designed for reuse and recycling, and which ones responsibly address packaging, water and waste. And the chemicals of concern impact area, eliminating the use of toxic chemicals that are hazardous to human health as well as the environment. And lastly, but very importantly, of course, corporate ESG performance, which is the responsible sourcing of materials, fair labor practices, and worker health and safety within the electronics supply chain. And in order to provide you with a more in-depth look at the specific ultra-low carbon criteria, I'll hand you back to Michael to cover that information.
Great. Thanks, Debbie. And Joy Payan, next slide, please. So just a quick reminder, these criteria are developed like all of the EP criteria in a multi-stakeholder process with industry experts involved, very transparent. All of the criteria are, the performance against the criteria is third-party verified, and these criteria are regularly updated to make sure that they remain current. So that's true for all of these as well as all other EP criteria. So I'm going to try to give you a broad overview of how these carbon footprint criteria work. It's quite a detailed set of criteria, but this gives you the high-level summary. So the carbon footprint calculations are life cycle based, and they are so-called cradle to gate. So they cover everything from quartz mining to produce the metallurgical grade silicon through polysilicon production, wafer, cell, and final module assembly. And they look at the carbon components all along that life cycle. It covers all of the major materials used in PV modules, including the frame. I note that because the French tender process did not include the frame. So if you're comparing the values to the French tender system, the difference is because we're including the frame in the footprint calculation. And life cycle analyses, the criteria for performing the life cycle analysis are specified in the EP criteria. The whole goal here is that the numbers are reliably comparable. And so there's quite a clear structure for what your life cycle study must look like. As Debbie mentioned, because EPEAT is a tiered eco label with bronze, silver, and gold levels, there are two different carbon footprint thresholds in the criteria. There's a low carbon threshold, and the measurement metric here is kilograms of CO2 equivalent per kilowatt peak for the module. And so the low carbon standard is 630 kilograms per kilowatt peak module output. Ultra low carbon is 400. And so to qualify for the lowest level of the EPEAT eco label, bronze, you have to meet the low carbon standard. And if you meet the ultra low carbon standard, that gives you additional points towards a silver or gold level EPEAT eco label. There are basically two approaches for calculating carbon footprint that are in the criteria, and this reflects the approach taken in the French tender program. Path A is a series of standard lookup tables for embodied carbon values. These are calculated from transparent life cycle inventory data from the IEA PVPS Task 12 life cycle inventory. And so these tables, you can imagine basically each component by geography. So if your module contains polysilicon from Germany, a wafer made in Vietnam, the cell made in Germany, and the module assembled, say, in the United States, you could look in the table and see the relevant carbon footprint value for each of those components, and then simply add them up. Obviously, it's related to the amount of material of each of these that you're using, but it's a pretty straightforward way for people to calculate their carbon footprint. And the idea here is, because this is a pretty complex system, the idea for Path A is to have a straightforward, relatively simple, low-cost way to develop a carbon footprint value without having to go through the detailed life cycle analyses, which can be expensive and time-consuming. But if you believe that your particular manufacturing or your supplier's manufacturing gives you a carbon footprint advantage that might allow you to get a silver or gold level EPEAT eco label, you could choose to use Path B, which is a site-specific life cycle analysis for the given component, whether such as polysilicon production or wafer production, following the life cycle methodology that's laid out in the criteria. To maximize efficiency for companies who want to pursue EPEAT, you can use either Path A or Path B for any given component. So you could use the lookup table for your polysilicon and wafer source, but if your cell and module manufacturing is particularly energy efficient, you could do Path B, the site-specific life cycle analysis for the cell and module, and then add the individual components up to get the carbon footprint. Another element here to simplify, The Path A lookup table values are based on national grid carbon intensity data as published by IEA. If you're going to use Path B for a particular component of the supply chain, that's the site-specific life cycle analysis, you can also use subnational grid carbon intensity data as published by IEA, and some countries have more than one grid. And you also can begin to use renewable energy up to 25% of the total energy consumption across the supply chain. The reason for 25% is I think everyone recognizes that most of this renewable energy would come through power purchase agreements, and the rigor and quality of power purchase agreement systems and the renewable energy credits or energy attribute credits that come from them is still varies in quality around the world. And so the goal here is to make sure that only high quality renewable energy projects are incorporated. And so there's the 25% cap, and you have to demonstrate that one, any renewable energy credits that or energy attribute credits that come from the PPA meet RE100 standards. They have to be retired, not resold for someone else's use. You have to demonstrate that renewable energy use is allocated fairly across the relevant manufacturing operations, by which I mean if you have a plant that has 6 different manufacturing operations on it, and only one of which is solar, you can't allocate all of the renewable energy use just to the solar operation. You'd have to allocate it across the entire manufacturing operation. And the renewable energy that you are purchasing has got to correspond with the same period of manufacturing that is covered by the carbon footprint calculations. So as you can see, we are obviously want to encourage the use of renewable energy as a key element of decarbonizing PV manufacturing, but we want to make sure that we don't open the door here for low quality RECs that might not actually represent genuine renewable energy generation for PV manufacturing. Because all of these criteria are reviewed every 3 years to make sure they remain current, it's our anticipation that as we gain more experience and as the quality of power purchase agreement systems increases globally, that the percentage of renewable energy allowed into the calculations will increase over time. Next slide, Dwapan. And then lastly, just to show you the level of rigor in this, obviously the carbon footprint of any given product is going to depend upon the mass of the components. So how much polysilicon is there in a wafer? How big is the wafer? And so the specifics of these components must be validated 2 different ways. You have to provide, lots of paperwork, documentation like invoices, receipts, purchase orders. You also have to account for loss and breakage during manufacturing, because not every gram of polysilicon that gets purchased ends up in a cell. You also have to submit the model of the module that you were seeking to register to an independent third-party laboratory for disassembly and measurement of the individual components to verify the information that's provided in the paperwork documentation. You also, Debbie, in her earlier talk about the general EPEAT approach, it is third-party verified by conformance assurance bodies that have been approved by the Global Electronics Council. And you have to, when you are applying for EPEAT, submit reports from independent inspections of your suppliers that were performed within the prior 12 months. And the conformance assurance body may go back and interview your suppliers to verify that, in fact, the information that they're receiving is appropriate. Further, the life cycle footprint calculations also have to be verified by accredited independent third-party life cycle analysis experts that has experience in PV and is also approved by the Global Electronics Council, and then subsequently reviewed by the conformance assurance body. Additionally, each year you have to verify that you continue to meet the carbon footprint and other relevant EPEAT standards. And so this is not a one and done kind of thing. You need to demonstrate ongoing compliance. And the Global Electronics Council does do routine audits to make sure that the companies are continuing to meet the criteria. And then lastly, the third-party life cycle analysis experts may themselves be audited by the conformance assurance body. And I believe this is my last slide. So how do you reduce the carbon footprint in the solar supply chain? If you were a manufacturer, how do you go about this? There are a number of ways to reduce carbon footprint at each step in the supply chain. I'll just review these briefly. Polysilicon, which is the most energy intensive component of the PV supply chain. Obviously, decarbonizing your incoming grid energy is a key element of that. So it is national policy for grid decarbonization, such as we're seeing in many countries around the world. We talked about the ability to account for renewable energy in your incoming grid energy, which obviously significantly reduces carbon intensity. There's also manufacturing energy efficiency within polysilicon production. How efficient your equipment is, your internal materials recycle, those sorts of things can have a big effect. And then inherently more efficient technologies. So in polysilicon production, the fluidized bed reactor technology is inherently more energy efficient and therefore lower carbon footprint than traditional Siemens process, for example. Ingot wafer, next most energy intensive step, pretty similar story. Reducing the carbon intensity of your grid input energy, using renewable energy, energy efficiency in the manufacturing operation, and then materials efficiency as well, such as recycling kerf or the very expensive silicon sawdust from sawing the wafers. There are also emerging inherently lower carbon technologies in wafer production, so-called direct wafer technologies that are getting closer to commercialization. And then if you look at cell, same story, reducing the carbon intensity of input power and energy efficiency manufacturing and efficiency in materials, reducing breakage, for example. Module, very same story, with the addition that there are some elements to a module that particularly large carbon footprints, like the cover and the frame. And there's a lot of work going on reducing the carbon intensity. Those include much higher level of recycle content. We're seeing some alternative frame materials develop, such as recycled steel frames and polymer frames. And there's a lot of work on reducing the carbon footprint of glass production. And we are also seeing some companies begin to use polymer instead of glass for the covers. There are also thin film technologies that are playing an increasingly large role in some markets like the US. And thin film is inherently lower carbon footprint because of the nature of the manufacturing process, but they can turn the same knobs to reduce their carbon intensity as well through reducing the carbon intensity of input energy and improving materials efficiency and the energy efficiency of the manufacturing process. And so there are, as you look at your suppliers, these are the kinds of conversations you can begin to have with suppliers about how they can reduce their carbon footprint, which in turn reduces the carbon footprint of your product made with the materials you buy from them. Do I put on the next slide? So what are the benefits of using an eco label? What are the benefits to a buyer from the use of ePeat for Solar eco label in their buying? As you know, there's a lot of push right now on better transparency and traceability in supply chains, largely because of the Uyghur Forced Labor Prevention Act and concerns about forced labor. The ESG criteria and the third-party verification that are inherent in ePeat definitely improve transparency and traceability in the supply chain. They also give you confidence in higher sustainability in your supply chain. A reduction in scope 3 emissions. So if you were a PV developer, this is your biggest carbon footprint is scope 3 of the materials you buy. And so this is one of the few knobs you have to turn to reduce carbon intensity of your operations, which is why Lightsource BP is going down this road. And if you have ever performed or reviewed a life cycle analysis, you know they are not easy, they are quite complex. And this simplifies all of that life cycle process for you by having third-party experts to do that to a common standard. And so this is quite easy to implement, and it's rigorous and reliable because of all of the checks and balances and third-party reviews involved. And so instead of having to look at LCAs, you can simply incorporate ePeat for solar as a specification in your buying, and you are assured getting low carbon, sustainably manufactured products. The other benefits are it sends a clear signal to your suppliers that you want better modules made with lower carbon and more sustainable manufacturing process. And that demand signal travels through the entire supply chain, because to get a low carbon footprint in a module, you need a low carbon footprint throughout that supply chain. And we're already seeing PV manufacturing expand in lower carbon economies because of this demand for lower carbon solar. And the other thing we believe it helps to do, you are all aware that particularly in the US market, but elsewhere, there's a lot of concern about long-term PV supply from the Chinese supply chain. And certainly India, for example, would love to decouple more from dependence on Chinese supply. And we think by sending this demand signal that drives more manufacturing in more places, we are de-risking the midterm to longer term PV supply by creating a more resilient and distributed PV supply chain. Okay. Now, with that, let me turn to Kelly Weger of Qcells to talk about, from a manufacturer's perspective, the value of eco labels. And Dwaipayan, I'll look to you for that introduction.
So yes, thank you, Mr. Michael, for that wonderful session. So now next forward, we have Kelly Weger, who is the Director of Sustainability, Qcells North America. I'm sure everybody's aware of Qcells. It's one of the largest companies in the USA. And Kelly, with her 16 years of diverse experience in the field of sustainability and her passion for energy efficiency and the renewable LCA, and her work encompasses all the aspects of sustainability in her company, beginning from products to processes to travel to purchases, so everything. So Kelly, if you can please start.
All right, thank you very much. And thanks for that introduction. So again, my name is Kelly Weeker with Qcells, and I'm very excited to be here to represent manufacturing side in terms of why EPEAT is something that we chose to pursue. Qcells as a solar manufacturer, we pride ourselves very much on being a leader in sustainability, and we're constantly looking for new efforts and new processes so that we can really demonstrate our role as a leader in sustainability. And I think the EPEAT process really helps us to establish that even further. One of the things that I think is incredible about the EPEAT certification is that rigor that Michael and Debbie referred to. The fact that this third-party validation, the level of transparency and traceability, this really helps to encourage others to look to us as a potential source for solar, because they have a higher level of confidence in the work that we're doing, and that we can demonstrate that what we're doing is validated by some other entities, such as the EPEAT certification process. Certainly, the effort that we are going through to pursue EPEAT certification will end up driving us to pursue additional reductions in Scope 3 emissions. Because of the nature of the tiered program, it naturally drives innovation and allows us to have external factors that will help us to justify some of the investments that we have already been able to make. I'm sure some of you may have heard that Qcells announced a very intensive investment in the United States with that goal of reducing our Scope 3 emissions. Next slide, please. So, we don't do this for nothing. We're in business to be, successful. Definitely, we are pursuing this, and internally, we are justifying the investments that we're making into this EPEAT certification because of the competitive advantage that we think that this will lend us. There are a number of factors for us here in the US. We believe that this will help us to gain additional market share with our federal government. We also know that we have a number of large customers that are specifically partnering with us. We recently announced a partnership with Microsoft, for example, and many others. And they are looking to reduce their Scope 3 emissions, and they're looking for a solar supplier manufacturer who is able to meet that need. So it helps us for strengthening those customer relationships, both existing and future relationships. And, I'm sure as many of you are, we're getting a lot of interest in customers that are asking us for a lot more detail about what we're doing in sustainability. And certainly those supplier surveys or questionnaires cover a lot of the same questions that we are going through the process of in the EPEAT certification. So it's really honestly been helpful for us, because previously when we would get those questions from customers, we would have to go through item by item, department by department, in order to find the answers to answer their questionnaires. We anticipate once we are able to achieve EPEAT certification, that will make that process more efficient, that we can refer them to the EPEAT criteria. They'll be able to see, and we'll have documentation already set up to clearly answer all of those questions that we get repeatedly on a wide variety of sustainability criteria. We also think this will help increase the market demand for lower carbon, sustainably manufactured solar PV. We are investing, as I mentioned, heavily in this idea. We announced a $2.5 billion investment in the United States. And right now, the critical pieces of solar panels are not made here. So the ingot, the wafers, the cells. And we are planning on changing that and investing in bringing that manufacturing domestically, which will yield a significant reduction in our carbon emissions. And we think that that is going to just further drive, not only for us, but for our competitors. And ultimately, at the end of the day, we are in business to reduce carbon emissions. So we don't want to just be the best one, the lowest carbon. We really want everybody to be focusing on reducing the carbon of an amazing product like solar. Next slide, and then I think I will turn this over to Debbie to wrap up.
Thank you so much, Kelly, for sharing that valuable perspective and, of course, your insights into how Qcells approached your review of eco-labels and EPEAT in particular. So that actually brings up an opportunity for me to address manufacturers or brands that are interested in starting the EPEAT registration process for their products. And you first need to sign a contract with GEC, confirming that you will, of course, meet all relevant policies. And that would fall under step 1 that you see here on the slide. And next, in step 2, you will choose a conformity assurance body. We refer to those as CABs, and you've heard that term several times today. So you would identify the CAB that you wish to work with. And just as a reminder, as I said, CABs are those approved, but they're approved third-party organizations that work with manufacturers to verify that their products and organizations meet all EP criteria as claimed. So moving to step 3, that CAB that you've selected will guide you through the conformity assurance process until your product is eligible to be made available on the EPEAT registry. Our Ecolabels team will issue a final approval and then guide you through the onboarding process and provide access to the EPEAT registry, which is our online database, so that you can add your approved products. And this, of course, this database is where purchasers and buyers actually come to find these products that are EPEAT registered. And finally, in step 4, once you have a registered EPEAT product, you are required to undergo periodic reviews, as Michael mentioned during his overview of the EPEAT ultra-low carbon solar criteria. And this continuous monitoring will also be done by your CAB to ensure that your registered products continue to meet EPEAT criteria. And next slide, please, Ryan. So as a supplement to the presentation today, the information that we've covered, we have included additional details on the following slides for all of you that you, of course, can review in your own time at your leisure. And so with that, please allow me to close out our portion of today's discussion by once again thanking all of our attendees for your time and your attention today. We greatly appreciate the opportunity to share information on the EPEAT for Solar standard and how it benefits both manufacturers of PV modules and inverters, as well as procurement professionals looking to actually purchase sustainable solar products. Joy Pine, I'll now hand everything back to you for the next portion of today's discussion.
Thank you, Debbie. Moving on, we have Mr. Subramaniam, who will be speaking. So just to give you a brief introduction, he is the youngest Chief Executive Officer of the National Solar Energy Federation of India. So NCEFI is India's largest umbrella body for solar energy ecosystems, which works in a complementary manner to realize India's solar ambitions, and it also represents the overall solar industry. Mr. Subramaniam is also the chair of the Renewables in the Agriculture Working Group at IRENA Coalition of Action, and also has been appointed to the UNDP Energy Governance External Advisor Group member. He's the recipient of the BRICS Young Scientist Award in 2018, and he also specializes in solar module reliability and has published several articles in international journals. So I hand it over to Mr. Subramaniam to give us more insight on this.
Hello, am I audible?
Yes, now you're audible.
I seem to have some problem in my PC. I think I was not audible for my PC, so I have joined from my phone. In the meantime, my PC, if I join, I'll switch on my video. Sorry for the delay.
No problem at all. Please, you may
Yeah.
continue.
So, and thank you very much to begin with to ISA for inviting me here, and it was very insightful to hear from all the three previous speakers here today. I mean, as a CEO of NSCFI, I would like to put forward my views here, but as a erstwhile researcher on PV module reliability, also I would like to bring some perspectives on sustainable solar today to this discussion. To begin with, over the last 2 to 3 years, especially after the onset of COVID, we did face key sustainability related issues when it comes to solar manufacturing, um, be it what has happened with regards to the uh, labor related issues or even related to the reliability of the supply chain, and of course most importantly the impact of domestic versus dependency on one or two countries has sort of come out as a wake-up call to the global industry, and India is also not definitely an exception there. uh, Now diving into today's specific discussion, I think the narrative has to shift from solar for sustainability to sustainability of solar. I am very glad that through platforms like ISA, we are now able to institutionalize and bring this discussion into mainstream. I definitely and very strongly believe that in the coming days, this is going to be an issue that should be addressed very, very proactively, not just by industry members or manufacturers individually, but also by industry associations and civil societies like us. On the second aspect, I have been very closely seeing the presentation of the ultra low carbon solar alliance, and I think uh, from an Indian perspective, to give all of you a context, although until 2021, we have been the largest import market for solar modules in the world. In 2021, Indian government has launched an incentive scheme called production linked incentives. It can be sort of considered as an equivalent of the America's IRA, but this is specifically aimed at or designed for high efficiency solar module manufacturing. Um, this is aimed at giving incentives to manufacturers for producing end-to-end manufacturing in the country. I think my system.
Recording in progress.
Yeah, I think I'm back in the system. So I hope now I'm audible. So yes, so Indian government has launched the production linked incentive scheme in 2021. The first tranche was around $500 million and around 10 gigawatt of end-to-end polysilicon wafer ingot cell and module manufacturing is scheduled to come through that PLI-1. In 2022, the second tranche of the scheme was again launched. The cabinet has approved another additional 2.5 billion US dollar worth incentives. And as of March 26th, we have the results of the scheme, and around 39 gigawatt worth of end-to-end manufacturing will be installed in India through this scheme. So as the outlook goes, India is looking at producing 100 gigawatt of solar modules by 2026, 2027, along with 60 gigawatt of polysilicon and wafer, and around 80 gigawatt or 85 gigawatt of cell manufacturing. When we are upscaling or rather accelerating our domestic manufacturing to this extent, I believe this manufacturing should proliferate in a very sustainable manner. We are very familiar with the eco design and eco label concepts in India. In fact, there are some subsectors of other industry which also follow similar guidelines. It is not compulsory to begin with, but there is an advisory pertaining to that. And I strongly believe that when it comes to solar, especially owing to the dependency on the rare earth elements and the process and the energy intensiveness of the entire manufacturing end-to-end process, I believe that the logical and the only way to go ahead is to ensure that every sub-segment of the process is as sustainable as it is. Before I leave, I would also like to remark that over the next 6 to 7 years, as India, we will of course emerge as the second largest manufacturing base for modules after China. But we will also be competing in the leagues of the United States and Europe, who are also equally poised to ramp up their domestic manufacturing capability. I think it would only be wiser to have a uniform and joint collaborative approach when we are deciding and finalizing the standards with a very thorough discussion from the industry. One of such things is today's webinar. I would again like to thank ISA for bringing this discussion on their platform. This will have a very, very positive impact when all the countries together talk in unison when it comes to standards. Last but not the least, I'm sure that when it comes to solar manufacturing, no country is isolated. There are intrinsic integration collaborations that are happening between, for example, India and EU, India and the US, and of course Australia also with India and EU. I think since we are already on the same boat when it comes to the manufacturing, especially in the lower level of integration below cells, ingots, wafers, and poly, it would be worth an attempt to start this narrative or discussion from that aspect in its infancy itself, so that when we grow, we are organically growing with the standards rather than having to switch back the gear once things are at a scale that are beyond the control. So these are my 3 inputs. Like I said, it is time to also discuss the narrative of not only solar for sustainability, but sustainability in or for solar. And I believe more and more such deliberations are required for us to come to a conclusion on how to go and proceed. And again, thanks to ISA, Dwaipan and Alex team for having me here. And I'm looking forward if there are any more questions. Back to you, Dwaipan.
Thank you, Mr. Subramaniam. It's an honor to have you as well. So I think we are running very short of time. I understand this topic is a very detailed and a very large aspect to cover in an hour's time. In fact, we had kept us time for Q&A, but I already see a lot of active things, active questions going on in the chat box. Mr. Michael, Debbie, whoever possible, they're answering the questions. So just because of the paucity of the time, I'll not be able to take further questions, but please do write back to us. I'll give our email ID at the end of the session. So just to conclude, thanks to everyone. And on behalf of International Solar Alliance, we thank all the speakers and the panelists, and it was a wonderful discussion. And as Mr. Subramaniam said, it's a topic which is extremely important going forward. And as we are proceeding towards the energy transition, such standards will become more and more important. And it is crucial for manufacturers from countries like India and other developing nations to be aware of such standards and the global trends, which will help us to decarbonize the supply chains and make them a major global exporter. So this is just a start of this discussion. We are definitely looking forward for more such healthy conversations and the support from all of you. And thank you so much. And at the end, I'll just request all the panelists, we'll have a photograph to commemorate this session, so that we can remember this again. So yes, Rajinder, if you can help us to do that panel view, then we'll all, and I'll take a picture of that. I think I could do that. One moment. So yes, thank you everyone. We are just on time. And thank you to all the audience who have been giving their questions. So then, thank you all the panelists. We'll surely meet again.
Thank you for the opportunity to speak with all of you, and thanks for all the great questions, everybody.
Right.
Thank you.
Thank you. Bye, everyone.
Thank you very much.